Now we'll see if YouTube is live. YouTube should be live. If YouTube is live. YouTube is live. And hello and welcome. And today we'll be creating a simple game engine with OpenGL. And the goal is to have a library that handles window creation, events, layouts, and to be able to use it from another project, which will be the actual application. So basically the int main function to be from the engine, and the application to not have to worry about that. And the first task will be to create a simple library. That's where the engine will be at. The engine will be a static library that we will use from our main application. This is the simple project we had created last time with OpenGL, and it is built using CMake. And the cool part is that now, before I had to close the application to build everything and run it, but now I've automated it. So if I press Ctrl B, it builds everything. So if I make a mistake here and I press Ctrl, okay, not here, but here. Okay, I have to save it. Okay, once I save it and build it, like it gives me an error that it's in main CPP on line 9. Here it is, line 9. I save, build again. It's working as it should be. And with F3, it actually runs the project. Look how cool this is. And that's happening by with the key maps, with these key maps. With Control B, it's just running the same command we have always run. CMake build with the build folder. Every project I'll just use build for the build folder as a name. And for running it, F3 is just like running the executable, which expects to be called my app, but it's not that big of an issue. And the first task is to create an actual library. That's what we'll do. And let's do it. We can create a folder, engine, like this. And inside of it, we need a CMake list txt, and we need a CPP file. A CPP file, and like, let's just do it test CPP, just so we're like testing. We're currently just testing. We will need a header as well. Let's update it to capital letter, and let's make another actual header file. And it should be like, let's see as a reference. We'll be using a lot of references today. The dev folder and CMake. And it was in step 1, I think we used. Yeah, this was when we had the stream about CMake, we created a library. This is what we will use. Okay, CPP file is just creating some functions. Okay. And that's what we will do here. Now we can make a namespace. I call it voxel engine. Because it will be for a Minecraft clone for the main channel. I call it a voxel engine. And we will have, how do they do it? Okay, it's just just a regular function. Our function will be like just printing to the screen. Void print to screen. And inside here we will include it, and namespace voxel engine, and let's actually implement it. I think we will need IOStream to print. And hello world from the library. End line. And in CMake list, we need we need this. So this is creating like as at executable is the same as at executable, but for just creating a library target. Engine, we'll call it engine. This will be the library name, engine. And for the engine, we need to give it the test CPP file, and headers, they will be public so that we can use them from the main project. And this will be the header file, test.h. And inside of here, the main project, we need to add a subdirectory, I think. This will engine, just that. And here we will link it, engine. Engine. Okay, there's an error. Cannot find no such dash L engine. My error. Oh, I think we need to like CMake build and then, or to maybe clean it. Let's delete the build folder and let's now build it. It's the same thing. Okay. Let me delete this part and delete this part. Now it's working. Let's add this part. It's working. Okay. Okay. So it's when I link libraries. What if I do it like this? Engine. How do we actually use the library? We used it inside of this project where we link, and here we just use the name math functions, which is the library name. We have engine. We add the subdirectory engine. Maybe we should change a bit the name. Oh, it's capital. My bad. My bad. Now it's working and let's use it. Include test stage. And what was the function name? Print to screen. We can have it at the start. Use of undeclared indent. We need to use the namespace. And let's build and run it. And here, hello world from the library. Hello world from the library. So the first task of creating a simple library is done. We use the library from the main project, and now it's the actual creation of the engine, which I already have one, my previous engine, and it's quite big. And it's using pre-make. It's using pre-make because I created it using the Chernow's engine series. This one, game engine series. And it was done in like Windows with the Visual Studio. And pre-make is like CMake, but it's much more simpler to use. And at the end it builds generates an environment for visual. It creates a Visual Studio solution, project, etc. to open it in Windows with Visual Studio. And pre-make can build for like Linux with it created these make files, sure. But when I build, when I do CMake, now if I do make, it's going through some of them, but when it reached our audio, it had some complaints. And yeah, it's possible to use pre-make, but I want us to convert to CMake. That's why we had the streams about CMake and learning CMake. I want to convert to CMake. And we will just take it part by part. And we will start with the most important part. We will move the application. Here, these errors are just like NeoVim complaining, but we will most likely not have them when we move to CMake. Because CMake will make a proper it will probably not have these errors. So the current task is to move the application class from previous engine to the library we just created. And that application is used by here. The application has the actual while loop. No, before that it was what was it? There was an entry header file. Entry point. Yeah, this is the entry point. Here it's commented out because the engine only supports Windows, but we'll move to Linux. So this header file has the main loop. This is what we need. The main loop. Yeah, so we can start at that point. Let's delete test CPP. We can leave it for now because it will create errors if we just delete it. Let's create entry point header file. And let's create it like this. Now, this extern, this is like a function. And this function, is created inside of the main project. There we will write the implementation. An extern means that the implementation will not be like here. It will be from outside of this project. Like that's how I remember it. Okay, we have here, this was the log system. We can remove it. This is the profiler. We can remove it. Remove this. Remove this. And remove this. Now, this is our entry point. Okay. We create an application using this. And then we run it. We will be creating an application class. So inside of the main CPP, we'll be creating an application class so that the engine can run. This is all because to have the main loop inside of the library. Where to go from here? Yeah, we need the application class. We can do that. Yeah. Application header, application CPP. And since we are just moving it, we'll copy. Now, we can delete this. On event, we can delete that. We don't have events yet. Yeah, this is the function that will be defined outside of here. Layer stack, we can remove that. IMGUI, we can remove it. Window, we'll just hard code it. But still we need like for the window like this. And what else? On Windows resize, yeah, this is for the events. Now, what's happening here? So the application class, these ones, these headers, we'll remove them as well. So the only error is here. Now let's see, we have a constructor, destructor, run and close. This will be handled from the the game engine. Push layer, we don't have layers yet. STD, or maybe here the solution is like include IO stream. Okay, I don't know, but we don't need layers yet. And push overlay, we don't have overlays. And get layer. Oh, maybe this is like, yeah. This requires, etc. I think I need to specify a like higher level of C++ version. Yeah, older C++ versions didn't have this. Get window. We need to include glfw. We need to include glfw. And for getting the window, we are dereferencing it. Let's just ignore it for now. Let's just ignore it for now, and this is our simplified application. And now let's get the CPP. One problem is that the previous engine is using precompiled headers. I'll have to remove them. I don't know how to implement them in CMake. Now, yeah, this is the profiler. We don't need it. Should we move the window? Yeah, I think it will be not that hard to remove the window. Yeah, we have to move for creating a window, the class. Let's create windows for handling windows. Here, actually, yeah, there's a bit of an abstraction here. It's done this way where we have a window header and then a Windows window header. Just so we can later on add like Linux window header, Mac window header. But we want it to be simpler. So I'll just copy the window header. I'll delete this. And let's copy the window header. So window header. We remove these. Okay. This is for the window, but it's all virtual. Because it can be like inherited and actually implemented with glfw or some other library. We can leave it. Yeah, we can leave it. And let's have our, I'll just call it glfw window header, which will be this file. And we can just include here glfw, no graphics context. Now, yeah, this will limit it to here. just application and a window and an entry point. Now we just have to make it work. What's the input? We'll see it later on. Let's create the CPP. glfw window CPP. Let's remove this. Error callback, we'll remove it. This is for the profiler, we don't need it. We don't need this. We don't need this. We also have the events that are missing, that we haven't moved as well, but we'll delete them. We don't need them. This is for the callbacks. Key callback, we don't need it. Window size callback. This is just for the event. And this is just for the event. We simplified it. Error callback. Yeah, we can implement it. We can implement it, and here it will be like just a regular std cout error glfw error, and then the description and line. IOStream. Now this is an assert, we'll remove it. Or like comment it because we'll need it for sure. Context, new graphic context. This is from the renderer. This is from the renderer. Graphics context. Man, turns out it's hard to like just move some parts and not everything. Now, what was this graphic context? This is just the constructor that saves the window handle. It saves the window handle, and glfw make context current. We can copy it. And where's this context save? Yeah, here. So instead of like this window. No, we need to think of a way to simplify this. It's not going to work out like this. Just moving parts will not work out. We need to move from passive work to more active work. This copying around and deleting is passive. We need to make it active by actually thinking and not just moving without thinking. We will do less moving around. Even, like, here is what we'll do. Let's delete these files. This application, will leave it. And we'll make it extremely simple. Let's delete these implementations. Delete inside here. On event, we don't need it. These words for the events. Okay, now it's a lot simpler. And let's move. We don't need this. We don't need this. These parts, will comment them out. We'll comment them out. We need just this. This will be inside. Let's do it here. And the while loop. The while loop will be in the run. And yeah, we can copy all of it. This as well. Now we need to include glfw, and we need glut. And iostream. And those as well. M window. So here it will be M window. And we just need to replace window with M window. And inside of here, use of undeclared identifier. We will update the CMake to be, it will need glut, glfw, glfw, right? and it needs but the executable needs to link with glfw, but so does the library. Here, let's do the engine to link with glfw. Here I'm including GLAD, including glfw. This is needed for glfw and adding glfw here. And for target sources, we need the GLAD file. We removed tests. We need application CPP. And in headers, application header and entry point header. And now we make add subdirectory. Oh, it's the wrong one. We are inside of the engine folder. Can we do backwards? Okay, here it's using the term out of tree. Maybe it's because we're going backwards. Oh, it's not a subdirectory. Yeah. So we are saying add a subdirectory, but actually external is not a subdirectory. We can make it a subdirectory by moving it. Yeah, I think for next few streams, I'll probably not. The next few streams will probably not be me doing this because probably you guys don't find this valuable. The previous streams were much better. Voxel? No, not the Voxel engine. The dev. We need to move the folder. Simple OpenGL project. So inside of, this external folder, we need to move it inside of the engine. That's what we needed to do. So here at subdirectory will be external glfw. Now, at engine, make list target sources. Target sources cannot find application. Application. Now it's building. In the application was not declared in this scope. Yeah, the same error. Undeclared identifier. GLAD and glfw. In included file, already included. Remove previous include. It's in. Yeah, we will include it in the header. Now, inside of shader CPP, that's from here. We should be able to have access here as well. So how to do that? We want like this CMake, have these directories included. We can just copy it like this. But here it should be like engine. Engine. Now it compiles. And in the main loop, we don't have anything. Except these imports. File not found. So we should... Yeah, we have to add it here. So engine, external, glut. Source, GLC. Source GLC. Why is this still complaining? Let's run it. Why is it complaining? What if I do include? Does it find it? Yeah, glut. GLH. Yeah, it can find it. Yeah, the error is the error is gone. The error is gone. And everything is moved inside of the engine. Like when I say engine, this is like far from an engine. But let's call it an engine. We have the entry point. Yeah, we should. Yeah, we have given. Okay, so in the main, we should be able to include entry point. Now. Yeah, I've made the entry point public. And in here, I've added the engine, a subdirectory. And I've linked it. And why is it complaining? Undeclared identifier. Oh, it's complaining from the header file. It's something, it can find it, it can find it. It can find it. Entry point, here is what's complaining. Voxel engine is our namespace, yeah, but let's look at the includes. Yeah, entry point. No includes. We actually, the way we did it, like the way it was done in the previous one, is like there was one single header file that we include. and that has all the includes. So you don't have to include, like do this every time you use the engine. And inside of here, there was entry point. Like, right? Where's the entry point? Where is the use of the entry point? Let's move to the clone. I know that I use it here for sure. And I include the voxel engine. Okay, so the voxel engine here has all of these. Let's do it like that as well. Let's do voxel engine header. This will have everything. Like include application header. And we make lists. Voxel engine. And so inside of here, we will just like, yeah, we would include the entry point, but the voxel engine. And look at how the error disappeared, because inside the voxel engine header, we include the application, which actually has the namespace voxel engine. Yeah. And we don't need this int main as well. So we don't have an int main, but we will need to create a class like application. It will be like game layer. Or like, no, this is for the layers. We need an actual application. My application, and it should inherit the voxel engine application. It should inherit that. And we should give definition to the static, to this one, to the static function. This is how we will connect. In here, return my application. It's pointer to like, let's see, yeah, new, etc. Yeah. But we need the semicolon. Cannot cast my application to its public. Yeah, that's it. Build, and now was the error. To create application, we make where is the complaint coming from? It's my app main, our main CPP file. In function main. Oh, it's in the function main. So it's like the entry point. Yeah. It's the entry point. Here include, let's say, application. Inside function main defined in a header file. can lead to, okay, this is just a warning, we don't care. So the app is, here we call the function create application, which is defined outside of here. That's what this extern is saying. We have the run function, and when the run function is over, we delete the pointer. And now we just have to build it, to compile it. Undefined reference to voxel engine create application in main CPP. Yeah. This is, so it's, yeah. So when we do an include, it's as if we have copy pasted it. It's the same as doing like a copy paste when doing it like that. So it's as if the main is here, the main function. And so it's complaining inside of here. It's undefined reference to voxel engine create application. Oh, it doesn't know where it is. Here, we've included application from here. Not used directly. That's not a problem. This is the entry point. But it's compiling. No, it's not compiling. It's the linking part. It just like headers, everything, like it can. There are no errors from that point. There afterwards is the error. Undefined reference to create application. How did I handle it here? So we have, yeah, voxel engine. Oh, sorry guys. Voxel engine. Yeah, the function needs the namespace as well. Yeah, and that fixed it. Can we run it? It's running and nothing is on the screen. So it's constructed and it creates a window and it calls its run. And it's clearing the color and drawing like a triangle, but it doesn't have a shader for the triangle to be drawn. Here, instead of doing these two lines, we want to do them from the main project, the application. But that was done by using layers. That was done by using layers. And this width and height should be happening from the main project. Yeah, here inside of the constructor, we're just pushing a layer. Yeah, that's what we're doing. So public my application push layer game layer. We're just pushing a layer. And the destructor is not doing anything. Yeah. But we don't have layers. And there are a couple of ways to do layers. And this is the like newer way that I did it. And this I think use like a newer C++ version. But the other way was like, I think like as here giving an argument. Like here an actual layer. Instead of with like templates. And the templates were helpful so that I could actually communicate between layers. Like with casting and etc. I'm wondering if we'll add the layers. Or a simpler layer system. A simpler layer system. Like here in the application. The application needs those functions where we push a layer. Yeah. But the implementation that I have is using a layer stack that handles all the layers. Can we use a simple layer stack as well? Yeah, it's... Was there a layer folder? Layer stack. So it just has a vector of the layers. I'm thinking of, is it possible to like simplify it so we can have a more quickly something to work with? Yeah, so the application push layer just calls the layer stack push layer. So instead of the application having to handle layers, the layer stack handles layers. But we can handle them inside of the application just quickly. Scope, I think, was defined in core. Like it was a shared or a unique. Oh, it's unique. The unique pointer. Yeah, a unique pointer. It was a unique pointer. Yeah, and we'll need layers. Oh my god. And the layers, oh no, we're not doing it. We're totally not doing it. Like, it's too much. Like, this cannot be done in like half an hour, in an hour and 30 minutes. No. We need. I was thinking of like something much more simpler than this. No. We'll just not have flares. Yeah. Let's just think. Let's just think clearly and not be bots. Void. This is the run. The layer hat. We'll just have one layer. That's it. Like it has on attach, on tick, on update. Yeah, on tick, like it's not used. On update. Yeah, for the application, we'll just have on update. And here it will be like float delta time. That's what we'll have. We will not have a layer system because like it's too much. It's too much. Application. And it will be on update will be called here. And for the delta time, what was the calculation? Yeah, it was this. Timestamp. It's time. Last frame time. Yeah, so we get the current time with glfw get time, which gives us the seconds since like starting since like glfw has started. And the timestamp is just the current time minus the last frame time. Do we have last frame time? Yeah, last frame time we have it, which starts at 0. And why is clamp complaining? No member namespace std. C++ clamp. What do we need as an include in algorithm? Include algorithm. Yeah, we clamp it and we give it here delta time. Now if we build push layer, yeah, we don't need push layer anymore. Oh, it's inside of the main part. The constructor will not be doing anything, but it will have on update float delta time. Void and like override, right? Virtual. Yeah. Now it's a dark screen because we commented out the actual implementation, the clearing of the color. We'll just do it inside of on update from here. Draw arrays does nothing. And that's not being called because we didn't build it. And now it clears color. So we have an application. So now we have a simple like library that in quotes we call an engine, but it doesn't deserve to be called an engine. And we are linking it with our executable. That's another project. And by doing it this way, we don't have to define a main function. We can just define this static function that returns an instance of our class that inherits the engine application class, which has a run function. It has everything that you need, and it's handled inside the library. We just come over and override the onUpdate function. It doesn't have layers, it doesn't have events. It's quite simplified. It's quite simplified. Move the application class to the library. We moved it with a lot of simplifications. Here I know this was quite ambitious when I wrote it. In reality, we can deal without layers. We can deal without layers and just do the event system and have the triangle follow the mouse, etc. But we need shaders as well. We need shaders. Yeah, this way of doing it is not compatible with streaming. I'll think of different way of doing it. We'll finish this stream, but like the other streams will not be this thing. So I was thinking of having events, but what else can we do? Like this shader should be moved inside the engine. No, we can even like just stop the stream here. Like, yeah. I'll have to brainstorm where to go on from here. This will be a shorter stream. I'll think of what is more appropriate to stream. This was not appropriate to stream. I should think of how to do it. Okay, bye.